This is a functions calculus question. So here we've got f of x equals x squared minus 7x plus 12. And they want you to find the value of f of minus 3. Rightio, what are we doing? We're going to fill in this minus 3 in here for x squared. So f of minus 3 will be, if they've replaced that x, you replace it with minus 3. That's the idea. We're going to pop all that into your calculator and you will get 42. And that is that done. Now, find f, the differentiated version of x, i.e. they want you to differentiate that curve up there. By the way, if you wanted to know, that is an x squared x in a number, which would be a U-shaped graph if it was drawn. I know that because x squared x's in numbers are either u's or n's, and in this case it's a u because it is positive at the x squared. So let's go and differentiate that. That will be 2x minus 7. How did I do that? Remember, x squared, there's really a secret one there. So 2 by 1 is 2x, and you reduce the power by 1. And then that minus 7x, this here, there's really a secret one there. 1 times minus 7 is minus 7. Reduce this power by 1, we'll bring it down to 0. So he'll delete. And then the number will delete. So f, the differentiated version of x, is 2x minus 7. They would then like you to work out what is the value of f, the differentiated version of x, equals 0. So you're going to write this down. 2x minus 7 equals 0. And you would like to solve for this x here. Letters on one side, numbers to the other. 2x will equal, this minus 7 will travel over here and become plus 7. X will equal 7 divided by 2 or 3.5, whichever way works for you. Right, the last part here before we go into a little bit of a more challenging portion of the question is find the minimum point of the curve. And I told you all, if you see the words minimum or maximum, that you should learn these steps off by heart. Differentiate, let the sum equal to 0, solve it, and then substitute it back into the original. And that will always get you the minimum or the maximum point. We've actually done all that already. We've already differentiated it. We've already let it equal to 0. We've already solved it. So our last step is 4, just to substitute into the original. Let's say you didn't know that though. You just do the whole thing again, all right? Now they specifically say, leave it in this form. Leave it in a over 2 and b over 4. So this here is what we're using. And just for a quick practice, I don't mind doing it again. So if I want to differentiate this, that will become 2x minus 7. Let him equal to 0. Solve him. Letters on one side, numbers to the other. So this 7 will come over and become a positive 7. 7 divided by 2. And they want you to leave it in that form. So the last thing is we're going to substitute him back into the original. You didn't have to do all those again. You could have just went straight into sub into the original. So I'm putting in the 7 over 2 specifically because it asked for it here like that. It wouldn't be a huge deal, guys. You might lose a few points if you didn't leave it in that format, okay? And let's see, when you pop him all into the calculator, you should get -1/4. I might give him a little double check there. and minus a quarter it is. So your coordinates are 7 over 2, comma, minus 1 quarter. So that would be like a functions part of the question. And then the one that people generally struggle with, where they ask you to find an equation of the tangent to that curve. So what I'm going to do is I'm just going to rewrite what my curve is so we can focus on the one page, okay? So f of x equals x squared minus 7x plus 12. So I'm just bringing that forward there so we don't have to keep flicking over and back. Now, just as a little reminder, f of x, that symbol there, or if you got g of x or h of x or any of those, that really means y, or alternatively can mean y. And when you differentiate a curve, this symbol here alternatively can mean the slope, okay? The slope. So find the slope of the tangent to the curve at the point 1, 6. I appreciate these are not formulas. They're functions. But you could kind of think in your head, if I wanted y at any point, this would be a formula for y. And if I wanted the slope at any point, this would be the formula for the slope, if you wanted to change the language to make it easier for you. So they want you to find the slope of the tangent at the point 1, 6. I do have a slope formula, the differentiated version of x. I always write it over in class to try and help you remember as much as possible. We have an x and a y, so if I fill 1 in for x, it will generate back the slope answer. Therefore, the slope is minus 5. They would then require you to find the equation of the tangent. That means the equation of the line. You'll find this formula in page 18 of the booklet. Tangent is just a line that is touching the curve, and we've got 1, 6. So I've got x1, y1. Y minus 6 equals m, the slope, which is minus 5, x minus x1 is 1. And we're going to multiply it all out. So that y minus 6 equals minus 5 times x is minus 5x, minus 5 times minus 1 is plus 5. They would like it in x, y number, which would be the usual way to put it. We love our x to be positive, so I'm going to carry these two over to this side. That'll give me 5x minus 5 plus y minus 6 equals 0, leaving me with 5x plus y, and minus 5 minus 6 is minus 11 equals 0. You should have lots of samples of this guy in your papers and things. He's definitely a little bit trickier, but with some good practice, you should be okay.